Hi everyone, I hope you are doing good. So today in this advanced C++ series, we will take a new C++ topic, that is fold expressions. And in this session, we will discuss the need of the fold expressions, like why it came into picture. And this is part of the C++ 17. In the C++ prior versions, it would not be there. And then we will see how to create a fold expressions, like how can we make use of the fold expressions, what is the syntax, right? So that we will see with examples, and then we will see how it internally works, right? How compiler expand this internally in the assembly file or at the compile time. So that also we will see, we will understand with the help of the dump files as well as the assembly files. Then we will see the expansion of the fold expressions. And then we will see supported arguments types in the fold expressions, and then we will see limitations of the fold expressions. So all these things we will see in detail with the multiple examples and with the C++ code as well as the dump file and the assembly code. So please watch the video till end so that your understanding will be clear once you are done with this session. And I would suggest you to watch my previous videos which are related to templates. In template session, I have explained about the templates in detail with the multiple examples. Then I have took the variadic functions, C-style variadic functions, and then you can see or you can watch the variadic template session where I have explained about the variadic templates, because this session is related to templates or variadic functions and variadic templates, right? So if you know all these three, right, templates, variadic functions and variadic templates, then this would be very easy for you to understand, right? So let's start with this one. So first, what is fold expression? So you can say need of the fold expression. So in I have explained in the last video about the variadic templates. So in variadic templates, what we were doing basically, we were adding, we were recursively calling the functions, right? We were having two functions. One is the base condition functions, and other one is the main variadic template functions, right? And there we have to write the multiple lines of code. But here, to overcome this overhead of writing a multiple line of code, we can write or we can perform an operation in a single line using the variadic using the fold expression. So that is what the need of the fold expressions, right? So prior to C++ 17, handling variadic templates often required recursion or helper functions to basically process parameter pack. That is what I have explained, right? And this could lead to complex and hard to read code. And then fold expressions simplify the process of applying operations to all elements in parameter pack, right? So earlier, as I said, we had to, or we used to write multiple line of code. We used to write two functions, one base and one main variadic template functions, to basically expand or process all the packed elements, right? Packed parameters. But here, using the fold expressions, we can basically do the same operation in the single line using the fold expressions, or you can say this is the simplify. It simplifies the process of applying the operations to all elements in a parameter pack. So that was the requirement of the fold expressions. They provide a more readable, concise, and syntax for common operations like summation, logical operations, etc. Right? All the addition, subtractions, right? Multiplication, division, logical operations, and or all those things we can simply apply in the single line using the fold expressions. I will also show you the some multiple examples. We will see. So don't worry. This is the theoretical part. So what is the fold expression now, right? So we have understand why it came into picture to simplify the code of the variadic templates, right? Using the fold expression, we can perform the same operation which we are performing using the variadic templates in single line instead of the multiple lines and recursions. So what is fold expressions? So fold expressions provide a concise way to apply binary operators to all the elements in the parameter pack. That is what I have explained, right? Without the need of the recursion or helper functions. And this recursion and helper functions will be needed in case of the variadic templates. That is what we have seen, right? And then they can be used with unary or binary operators and can be left fold or right fold, right? So this is the main thing. It could be either left fold or right fold, right? And right fold or left fold in terms of the like pegged elements or pegged parameters, right? Uh, this is the syntax of this fold expressions. So the pack, then operator, and then this dot dot dot, right? So it is right side. So that is why it is called right fold, correct? And here first we have dot dot operator and then pack. So the dot 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 is left of the pack. So that is why we say this is unary left, right? Here we are having only one operator. That is why we say unary, right? So this is unary left and unary right, correct? And likewise we have the binary left fold and binary right fold, right? So for left and right you have to like you can remember by just thinking of, right, this dot 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 is the left side, then it is the left fold. If it is right side of the pack, then it is the right fold, right? And if we have one operator in the syntax, then it is unary, and if we have two operators in the same syntax, then it is binary, right? And in case of binary we can initialize, right, this the values whatever the after these expressions, right? So for example we are applying this operator on this complete pack, then we can initialize the initial value, we can also give the initial value basically, right, in the same syntax, same expression. So that is why we use the binary here, right? This is init is the initialization or initial value basically, you can say. So we will see with the examples. The operators could be, as I have said, plus or this one, all the this mathematical operators and logical operators, or comma, whatever, right? And the example here you can see this template, uh, right here, variadic templates here, and then we have our function, then argc dot 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 and arg, right? So this is the packed, right? We have seen this packed, this pack in case of the variadic templates as well as right in the variadic functions. And here this is the operator, this is our pack, and this dot dot dot, and this will it will do, it will basically apply this plus operator on all the basically parameters inside this pack, right, or in this list, and then it will return. That is what the operation of this function. So here now we will see how it works internally. So basically what will happen at the time of compilation, so this pack will get expanded, right? The pack will get expanded by the compiler at the compile time. So we can basically verify this by seeing the assembly code as well, or we can dump the compiled file and then we can also verify. So that we will do it, right, later on. So the compiler expands the fold expression by applying the specified operator between all the elements, right? All the elements of the parameters, right, of the pack. So whatever the elements or whatever the parameters are there in this pack, this plus operator will be applied, right? So that is what will happen. And here, for example, this is or fold expression, right? This is the pack, then this is the operator, and these three dots are there, right? And so remember this bracket must be there. This is part of the syntax, so you cannot basically omit this one, right? And how it will get expanded? So this is what, like if we are passing the 1 2 3, then it will get expanded to 1 plus this bracket, then 2 plus 3, right? So likewise it will get expanded, correct? This is the right fold. Now this expression is done at the compile times, as I have seen, as I have explained. This will happen at the compile time. Compiler will do it, right? This is the responsibility of the compiler to expand this one and then apply the operator on all the operands, or you can all the parameters inside the this parameter pack, right? Then if the parameter pack is empty, the behavior depends on the operator used with the whether it is initial value is provided or not, right? So if we are passing the empty parameter pack, then it all depends on the initial value. For example, this one with empty pack results in a compilation error, right? Because binary, this plus operator cannot be applied on the empty operator. But if we are giving the initial value, right, using the binary operator, right, in that case it would give the 0, right, because 0 is the initial value, so it will return this one. So that will depends on the operator, how and the initial value basically, how and where we are using the empty pack with which operator, right? So I hope you understand the how it internally works. Compiler, it's compiler's responsibility to expand the pack and apply the given operator on all the parameters of that pack. So now supported types in the fold expressions. It supports all the arithmetic types, integer, float, double, etc. for operators like plus or this, and boolean operators. For logical operators, it supports the boolean types as well, right? For user defined data types, we have to overload that data type. For example, we have a custom class, and that custom class will not support the arithmetic operators by default, right? So for that, what we can do, we can overload the operators in that class, right? In that case, it will work. Pointers and smart pointers for pointer arithmetic and comparisons. So these are the supported common data types, right? For user defined data types also it supports. Right? I have explained in the variadic functions, right? It does not support the this user defined data types, right? Then the variadic templates came into picture, and there it supports, correct? So the limitations of the fold expressions: the fold expressions can only be used with binary operators. Unary operators cannot be directly applied to the parameter pack, right? So this is the limitation. The require at least one element in the parameter pack unless an initial value is provided, right? That is what I have just said. If the pack is empty, then all it depends on the operator, or you can say the initial value. Basically, if the initial value is given, then we will get that as a result. Else, it could be a compile time error or undefined behavior. So let's have a look into the examples of the fold expressions. So this is the first example where what we are doing, we are basically summing all the arguments using the fold expressions, right? So here this is our function. The return type would be auto, right? Or you can give the exact type, that is fine. And here this is the templated one, and this is the templated pack, right, of types. And here we are this is the data type, right? And this is the argument pack or parameter pack, you can say, right? And we are using the fold expressions here. I have shown you the syntax, right, where this is the pack, this is the operator, and then three dots. So it would be right side, right, of the pack. So it would be right fold expression, right? Correct. And then it will get expanded at the compile time, and we will get the result, correct? So this is the first example of the right fold expressions for the summing all the arguments, right, using the fold expression. The second example with the logical operators and logical and, right, this also we can apply, so it would be same, correct? And then third one would be for printing all the arguments using the fold expressions with the comma operator, right? So here what we are doing, we are getting the pack of the parameters, right? And then we are giving cout, and here see this is the O stream operator, right? And we are using this is as a binary, correct? So and this is the pack. So the three dots are left side of the pack, so it would be binary left, right? Or you can say binary left fold expressions, correct? See here two times we are using the operator, and that is what I have explained in the here, right? This one. This is pack right side, then this one, and then two operators, right, and initial value. So this is the left fold, right? So these are the some examples I have added here. uh, there could be multiple examples, right? With multiple operators you can use of these fold expressions. And here this is the call, right? We are simply passing 1 2 3 4 5, right, this one to sum, correct? So here this one, and the second is the all true, right? So here we are passing the list of booleans, right? It could be as it is the fold expressions, or it is the second version of the variadic template. So the number of arguments, number of parameters could be anything, right? It could be 1 2 or whatever, right? uh, right? So that is why we are passing it 3. We can pass 2 or 5 or whatever you want to do, right? And all are as a boolean values. And here we are applying the this values with the logical end, right? And we will get the answer from here. Then we have the print all function, right? It will print one by one all the parameters, right, that we are passing as part of the fold expressions here. See, so first is hello world, and then the fold expressions are cool, right? So these three parameters will be passed, right? And it will be part of this argument pack, and it will get expanded here, and then it will be basically printed on the console using the cout operator, correct? I hope it is clear. And then this is the concate functions we have added to concatenate all the this string arguments here. So basically these are the strings, right? C++ 17 fold expressions, and here we are using the binary left fold expressions, correct? I hope it is clear. You have understood the syntax, you have understood the how can we make use of the fold expressions, right? Simply you have to if you know the template, variadic templates, right, then it is very easy, right? It is basically the improved version of the variadic templates, where we used to, in terms of the variadic templates, we used to use the recursions, but here we are simply writing expressions, that is the fold expressions that we call, and then using that fold expression, we are applying some operators on the all the packed parameters, right? Let's compare the variadic templates and this fold expressions quickly. So here, basically, I have added some recursive variadic template function, right? So here, this is the base function, and this is the variadic template main function, right? So here, in the template, we are taking two arguments, right? First one, and the second one would be the pack. But in case of the fold expressions, we are taking only pack, right? All the arguments, whatever we are passing, that will be stored in the pack itself, right? But here we are taking one extra data type, basically, right? A templated argument here, and we are also, this is also part of the function as well, right? T first, and then this args pack will hold the rest of the arguments except the first one, right? And here recursively we are calling, right? And when we have only in the argument list, if we have only one argument, in that case this base function will get called, right? And this recursive calls will get terminated, correct? But in the fold expressions, we have, it's simple, right? We have only one line, but here we are calling the recursively itself, and then we have to add a separate function, base functions, to terminate the recursive calls. So this is the difference, and this is the drawback of the variadic templates. That is why fold expressions came into picture in the C plus as part of the C++ 17. Correct? So this is the left fold, right? And it will get expanded like this one, right? First 1 plus 2, then plus 3, then plus 4, and then the result will be get returned, right, from here. I hope it is clear. This is the call would be same, right? Because in the first call also we are passing the list of arguments, and the second also we are passing the list of arguments. The difference is, in the first call, in case of the variadic templates, the first argument will go to the first templated arguments, and the rest will go to the pack, right? But in case of the fold expressions, complete list of arguments, list of parameters will go to the argument pack, or this parameter pack, right? And here there is no any recursive calls, or any recursion is not there, right? In case of the fold expressions. I hope it is clear. So let me generate a dump file and a assembly file, and I will show you the difference there also, because it is a template, and when templates came into picture, then the compiler will expand this template into the separate functions, right, according to the caller, or you can say past arguments. It will create a different definitions, right, and then it will use those definitions, correct? So here we are expecting only one definitions, because it would be same, right? But here it will get expanded like this one, right, at the time of compilation. But here you will see one definition will get created for this one, right, because it would be same, data type would be same. But here data type would get differ each and every time, because first argument would be same, but this list of arguments, it would make a difference. First time it will get 3 arguments, so it is the type of 3 argument list. Second time it will get 2 arguments, so it is the type of 2 argument list. Then 1 argument list. So likewise it will like this definition will get created each and every time, right? So let me show you the dump file here. So I have searched the main here. So this is the main function, and from here you will see this is a basically a compile file which is dumped as a readable, right? So here this is the variadic template. This is our function, and here we are passing the 4 arguments, right? So let's go to the definition of this one. So first definition is this one, where the first argument is going into the T, right, and the rest 3 arguments are going into the pack args, right? Let me show you in the C++ here. The first argument is, here we are passing 4, right? First argument is going to the first here, right, first data type, and the rest are going into the args, or you will see in the templated as well, right? First will go to the T, first will go to the T, and rest will go to the args. That is what it is happening here, right? First is going to the T integer, and the rest is going to the list of best parameters will going to the args, correct? And it is getting applied here as well, right? and then from here we are calling again. See, we are calling this 3 integer, correct? It is a templated. So here the arguments we are passing is 3. So for this it will get a new definition, right? Earlier you will see here we are calling with the 4. So one definition for the 4 data types, or you can say 4 arguments, but here we are calling with 3. So it will have a separate definition for this one, right? So let's go to that. And here you will see first argument will go to the T, and the rest that is, those are the 2 only. So that will go to the ARGS, right? And it will count again with the 2 arguments. So new definition will be there, right? So let me show you that also. So here first from among or you can say from those 2 arguments, the first will go to the int, and then one will be remaining. So that will go to the ARGS list, right? And then we will call our functions with the one argument only, and for that we have a separate functions already, right? We have provided the termination function, this one. So this will also get resolved because this is a templated one, right? So let me show you this definition for this one also, this one, right? So this is the here, this is the last function, and from here we are not calling anything, we are just returning the value, right? So that is what it is happening, and from here it will get returned, or you can say it will get terminate the recursive call. So I hope it is clear where for this one we get a separate definitions in the compile code, and this would have a separate definition, right? So the compiler will create the multiple definitions for this one, right? But now let's see the fold expressions. So here if I go to the main again, because from main only it will starts, right? So this is the fold expression. So now if I go to the fold expressions here, see only one occurrence is there, one definition is there for the 4 integers, right? And 4 are part of the ARGS only. And here you will see this one, this line, right? 3737 line number. Here this is getting expanded, right? Here this line, this return line, ARGS, and this one, this left fold expressions, it is getting expanded at the compile time only. You will see this one, right? Only one definition, and the expansion is happening on the fold expressions, left fold expressions, right? That is what I have explained you. I hope it is clear, and let me show you the assembly code as well as. So here we will start from the main. So this is our main function, right? And from here we are calling the variadic template, right? Variadic template function, this one. So let's go to the definitions, and here you will see 4 arguments we are passing, right? 4, 3, 2, 1, right? So these are the arguments we are passing into these functions, right? And then let's go to this one here, and this is the definition of this one. And then from here we are calling again variadic template function, right? With the 3 arguments, right? This one, 1, 2, and 3. So these 3 arguments we are passing to this one, right? Let's go to the definition of this one. Here we are coming, and here we are again calling the variadic template function, right? With 2 arguments, this one 1, and this is 2, right? With these 2 arguments we are passing again. Let's go to the definition of this one, and here also we are calling again this one with the 1 argument here, right? Let's go to the definition of this one. And here we are not calling anything, we are just returning, right? We are just returning, we are not doing anything from here, correct? So these many definitions are there in the compiled code. So let's see the fold expressions. So let's go to the main again, and we will see the fold expression, right? Yeah, so here, so this is the variadic template call, and this is the fold expression call. So for fold expression you will see only one definition, so this is the only definition, right? And here in this definition you will not see any call statement, right? Because it is not calling anything, right? And you will see here this is first element is getting moved to EDX, second is getting moved to EX, right? These are the registers, EDX and EX are the registers. So I will take a separate session for this assembly course, how the functions getting called, or how the functions getting performing the operations, all these things. If you want the session, then you can comment below the video. I will take a separate sessions where I can explain you how these are basically happening, right? So these are the registers EDX and EAX. Two arguments are getting moved to this, and then we are performing the add operations, right? Then again we are taking one more elements, and then we are performing the add operations, and again we are moving one element to EAX, and then we are performing the add operations, right? So this addition, this part, right? I have explained you this one. So this is getting expanded, or you can say this is getting calculated at the time of compilation only, right? And we can verify by seeing this code, assembly code here itself, right? And then we are returning from here itself, right? So I hope it is clear that the expansion of the templates happens at the compile time, that I have explained in the compile session as well. And here I have explained you that we will see multiple definitions of the Variadic templates in the in the assembly code, right? As well as we have seen in the dump file, right? So we can say that this is getting expanded at the compile time into the multiple definitions, but the fold expressions getting expanded at the compile time with only single definitions, right? And this is also, and we can say this this operation, this operator is getting applied to all the parameters in the parameter pack at the compile time only, right? So it will calculate it at the compile time only. And here these are the calls from the main. So I hope it is clear till now. And I have added one more example here for fold expressions. So this is the sum fold, right? This is the template, and then this is the argument pack, parameter pack, and here we are performing the same operations plus operations. Anyway, I have explained you. Let me show you the code for this one as well, dump file. So here, if we go to main, and from main we are calling this sum fold here, right? With the 5 arguments here, right? This is a templated, so it will get added by the compiler, this data type explicitly, right? Sum fold. So let's go to the sum fold definition. So here this is the sum fold definition. Here you will see this is getting expanded at the compile time here. Argument 0 plus 1, then the result of this one plus 2, then the result of this one plus 3, then the result of this one plus 4, right? So it is getting expanded at the compile time only. And in assembly file also you will see sum fold, right? So this is the main, and from main we are calling the sum fold, this one. So this name is the mangled name, that is why you will see some extra characters here, right? I hope it is clear. And then let's go to the definitions of the sum fold here. So this is the definition which starts from here and ends here, right? And here also you will see the same. The first argument is getting moved to EDX, second is moved to EAX, right? Two are getting added here using the add operation. Then the third one is moving to EAX, and it will get added with the result, right? Using add operations here. Then again third one is moved, fourth one is moved, then fifth one is moved and getting added here, right? And we are returning from here. So I hope it is clear, right? How it is getting expanded at the compile time. So comment below the video if you want a detailed session about this assembly code, how it is getting it is happening here, right? What is this aid? Why we are taking aid here in the EBP, right? ESP, EDX. These are the registers, right? So don't worry about this. And if you want the detailed session, then please comment below the video. I will take a separate session about this assembly file, right? And I will explain there with the some stack maps as well, like how these are happening, right? How the data is getting pushed into the stack, and how the data is getting used, right? How these these operations are getting performed. Everything I will we can take in the separate session. Else it will be a longer session, right? So I hope this topic is clear to you. What is fold expressions, right? How can we use the fold expressions, syntax of the fold expressions, right? How it internally works, that also we have covered by seeing the dump file as well as the assembly files, right? And we have seen the supported types as well. It supports everything, all the data types. For custom data types, you have to overload the operator, right? So thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.